All right, so the rational function is this whole chapter, and that's this function 1 over x, and we talked about it before, and it looks kind of like this. Remember how it's got asymptotes both ways? It's kind of curvy, and it's got only 2 points that are really important, this point and that point. Do you remember that graph? Okay, now if I were to do what I have on the board here, right here, and move it this way and then that way, what would this mean? Where would I move it for this? Left 2, and how about that? Down 5. Okay, so I take this and move it 1, 2 to the left, and down 1, 2, 3, 4, 5. There it is. Okay. I just want to remind you about that because that's going to be important in a second. Okay. Do you get that x minus 3 and x minus 3 would cancel, and when they cancel, they don't disappear, right? They make 1s. So they rate y equals 1 over 1. That's not an x, it's a 1. Okay, and 1 over 1 is y equals 1. What is really the difference then? Is this exactly the same as y equals 1? Well, the graph of y equals 1 looks like this. Now, doesn't that make sense? Except, how could two things that look so different from each other actually be the same? Recording again. All right, so I would like you to take a look at that and see what you think happened on the graph that makes the difference between the two. Here's the one before. Here's the one, here's this one. Do you get that little circle in there? That is called a hole in the function. It's like it's got a weakness. When you hit 3, all of a sudden, it can't work anymore for just a second. And then it starts working again at 4 and 5 and 6. What is special about 3 that makes this thing not work? Yes? Yes, there's a 3 in it. The top being 0 is actually okay. 0 is just a number. It's 0. It's between -1 and 1. But when there's a 0 on the bottom, that's the only number of all the numbers you can put in that causes the bottom to crash. You can't have anything over 0, including 0. If you have 0 over 0, that's bad. If you have 5 over 0, that's bad. You can't do it. If you type it on the calculator, it's an error. Okay, so it doesn't like a 0 in the bottom. So that's what happens when you have something cancel like this. It creates a hole in the graph. All right, next thing is where it won't be so obvious. Take a look at this one. Do you see that the top could probably be factored? You just got done doing a ton of factoring, right? Would you please factor that on top and then write in the bottom too? And then you'll have a nice little equation that has 2 parentheses on the top and 1 on the bottom. Need some paper. On the bottom, we have x minus 3. That hasn't changed. On the top, we have factored out an x. And then we'd have what? X minus 3. Okay, and now watch what happens. Cancel, cancel. Those are gone. What am I left with? Y equals x. See? Now, what is the graph of y equals x? A lot of kids forget the simplest ones. Do you remember what that one looks like? If you know it, draw it with your finger kind of in the air. Show me what it would kind of look like. That is correct. It goes like that. Y equals x is like 2 comma 2 is on there, 3 comma 3 is on there, 4 comma 4 is on there. That's the line y equals x. And if I wanted to show this line having a weakness right there, the Achilles heel, so to speak, of this function would be where 3 would cause a problem. Do you get if I put a 3 in right there, that there'd be a 0 on the bottom? So 3 causes the problem. So I go over to 3, toot, 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 and then I go up and I'd say right there, there's an empty spot. It can't work right there. Now I have a special thing to put in there. Oopie. Get my line back again there. Okay, and I have it over here. And this little thing, and there's, I've got a pre-made hole that I can put in there on my graph. There. Okay, got an empty spot. That means that at 3, nothing happens on the graph. It's an empty spot. Question? Because 3 is the number that will crash the function. Yep, if I put a 3 in there, it causes a problem. All right. So that's how you make a graph that has a hole in it. I'd like you to do this one, start to finish. Make a quick sketch of it. When you're done with it, the first step is to factor it. Second step is cancel something that makes the whole. Third step is to see what do I have left once the whole cancels. And graph it. And don't forget, you got a little empty spot, a little hole on your graph. Don't try to just go right to the graph. You got to do the canceling part first. See what you have left. Now, since you know we're going for holes, do you get that you can probably just jump right to one of these is probably x minus 3? It's not a guarantee, but it probably is, so that it'll cancel. You know what I mean? And then you can say, well, if it was a negative 3, what would the other one have to be to make a total of negative 6? Positive 2, and that ends up working. If you check it, the outside and the inside make negative x just like you want it to. All right, so what does that mean? That cancels, and y equals, what do I put on top? Nothing? A 1. And do you remember what the parent of this one looks like? So I think we call it the butterfly, right? Kind of looks a little bit like a butterfly. That way you've got this, these are like the wings. And then here's, see, butterfly with a crooked antenna. Anyway, okay, so that's the parent of it, and so the whole thing moves, and that's a really rough parent. Technically it goes through this spot right there, so technically it's that. Anyway, its parent has been moved 2 to the left, so I'm going to take these 2 parent points that are really the important points on the graph and move them 2 to the left. 1, 2, 1, 2, and then I'll put in my asymptote lines. And now I'll put in red, and how about blue? No, I already used blue. How about green? I'll put in the actual graph right there. And a lot of kids get through all of this, and then they're like, oh, phew, we did that right, and they forget something. The hole. Where was the hole going to be? That is what crashes the graph. Now, you're right that this also crashes the graph, but that's the asymptote. The asymptote's at negative 2. See, that's a problem, too. When you get here, to this spot right here, there is no answer because it's an asymptote line. So that's a valid point, but the hole isn't at 2. The hole is at 3. And so if I'm going to put in a hole at 3, I go over to 3 and put an empty spot in right there. Pull it over from this. There we go. Got an empty spot there at 3. Okay? So that's the new thing for today is about holes. Now, they get a little more complicated, of course. What if they give you the picture and you have to figure out the equation? All right, I want you to shut your iPads down. Just hold them down so you can't see them. And I want just your eyes focused on this graph for just a minute. I think it's good to shake things up a little bit. Some people still haven't shut their iPads yet. All right. Okay, stay focused on this, please. All right, now, I want you to envision, ignore this one for a second, that line right there. Ignore the hole for a minute, and what's the equation for it? Y equals 1. Very good. And then, if I know there's a hole at 5, do you get I have to put in something that cancels here, and what would it be? X minus 5 and x minus 5. See? There's the answer. There's the answer for that equation. How do you write the equation for that line? You start by saying what it is, and then you say what the hole would be, and throw it on there. All right, now I'm going to go to the other one and say, how about this one? Ignore this one for a second. Okay, what's the equation for that one? Ignore the hole for a minute and just say, what's the equation for that line? Y equals 2x, not minus 2. Where's it touching? Touching at plus 4. So you're touching right there. So touching at 4. There's the equation for that line. But I got to throw on something on top and something on the bottom. And where is the hole happening? And you have an x plus 3 and an x plus 3 because negative 3 here is the thing that would cause the problem. And a negative 3, if I put it in now, would cause the problem. Why not? Why 2x? Because the equation for this line has to have a slope of 2. Look at the red line. Do you get it as a slope of 2? That's why I say 2x. And it's going through 4 for the wires up plus 4. And then I throw in this extra thing like this. One last thought. If you had it this way, I would sadly take off a half of a point because of something. Do you know what is wrong? There's only one thing different about how I wrote this than all the other ones I showed you. It's not a one missing one. There's something missing. Parentheses. Good job. That's between parentheses. Okay, now it's right. Because otherwise, see, the difference between this and the other one is this one, both the 2x and the 4 are going to end up being multiplied out. Whereas the way I had it before the parentheses, only the 4 would get multiplied in here. And there's a big difference there. Okay, so you need parentheses around this. Okay. Next kind. I just want to remind you about domain. Domain means all the numbers that work and are not going to crash my function. Do you get that there's one number domains about x's, as I move across the x's here, there's one number, right there that's going to cause a problem. What number is not allowed with this function? 0. And there's another one that's not allowed right there. You're right, 3. But there were two things. One of them was not allowed because it caused an asymptote. So the domain of this thing is all real numbers work except x cannot be 0 because that causes an asymptote. And x cannot be 3 because that'll cause a hole. So domain is everything that works, right? And so you start by saying everything works except a couple things. The only things that don't work are you can't put in 0. Excuse me, gentlemen. Okay, that's enough with the chair. Put the chair back, please, and sit in a regular chair. Thank you. Slide the chair over. Stay focused, please. All right, so, and there's another thing it can't be, which is 3. I'm up here. Okay. Now, the equation for this one, it's really pretty easy. If you know that the parent function is y equals 1 over x, what do I have to just throw in and add on? What does this have that graph doesn't have? It has, no, that has an asymptote built in automatically. It's 1 over x, except there's one extra thing I need. The whole. And how do I create the whole? X minus 3 and x minus 3. Because when that cancels off, I'll just be left with y equals 1 over x, which is what I want. And then I want this to have a weakness at 3. Do you know about Achilles? You know the story of Achilles? Why they call something an Achilles heel? Achilles had a weak spot on his heel. That was the only place you could hurt him. Otherwise, you could, stab him with an arrow, cut him with a knife, it wouldn't hurt him. Because Achilles had been dipped in the river Styx. That was the myth about Achilles. And how do you dip something? You have to hold on to it when you're dipping it, right? So when his mother was dipping him in the river Styx, she was holding him by his heels. He dipped him in, pulled him out, and that made him impervious to everything except where she was holding him by his heels. That's the story behind the Achilles heel. Okay, well, these all have an Achilles heel. They have a weak spot. They have a hole. Okay, and so this has a weak spot or a Achilles heel right there. All right, here's a typical problem for today, and I want you to take your iPads back out, and I want you to see if you can answer this one with me, and the next one I'll have you do alone. Do you get them, and I want to factor that? You should be pretty good at factoring. You just came off your test yesterday, so would you please factor the bottom of this thing and write it out for me? Once it's been factored. You'll need the top and the bottom. Top's already factored. Bottom. Wouldn't you assume I'd probably make one of them an x plus 2? Okay. And you can't be sure of that, but I would guess, just that we're in the concept is that we're about as holes here. It's probably going to make it so that cancels. And then if there is an x plus 2, the other one would have to be x minus 2, right? And I check and see if it works, and I go outside and inside, and that gives me the middle term of positive x. So it's right. Okay. Oh, what's wrong with it? 2 times 2 does... Oh, see, I only checked the middle term, and even that was messed up. How about this? How about now? All right? All right. Good. You guys are actually paying attention. That's awesome. I did make the mistake, honestly, but I'm happy that you were paying attention. All right. So now I have something canceling here. That creates a hole. And yes, it's true that the hole is at x equals -2, but I want to jump right away to saying, isn't a hole really a point? So it's -2 comma something, right? We're going to get to that tomorrow. For today, I can just let you write the hole as x equals -2. But for tomorrow, we'll say where exactly is that hole, and it's really not that complicated. You take the 2 and you stick it in here, and you see what you get for an answer. When you stick in -2 here, and here, and here, you see what you actually get for your answer, okay? And it'll tell you the y of where the hole is. Okay, but we'll do that later. For today, you can just say x equals -2. Next thing, the vertical asymptote. This right here, remember how there were 2 kinds of ways you can get disrupted on a graph? It can either be a hole or it can be an asymptote. If the hole has been canceled off, anything left on the denominator that could also cause a problem, that's the asymptote. X equals what would cause the problem. X would equal what? So that's the vertical asymptote. So things that crash your function are either holes or asymptotes. And there were 2 things on mine that would crash my function. Get them both back here. These 2 things would crash my function if it was -2 or if it was 1. The hole was the one that was on the top and the bottom. And that would be x equals -2. And the asymptote would be the other one. It didn't cancel. X equals 1. And what's your domain then? Your domain is all real numbers except those 2 things. Except your vertical asymptotes and your holes. So the big R stands for all real numbers, except x cannot be 1 and x cannot be -2. That's all the new stuff for today, and I'm going to explain it a little more thoroughly, but that's all you have to know for today is domain, verticals, holes. All right, so let's look at problem 2. What do you think the first step is? Factoring. Yes, sir. What an asymptote is. Back to this picture. Not that picture. Not that picture. There's a good asymptote line. Hold on. On this one, remember how these dotted lines, you get closer and closer to them, but you never actually touch them? That's an asymptote. And the asymptote is a line at x equals whatever, and this is a line at x equals 0. If I had another graph where I had an asymptote running like this, and let's say it's at 3, then there's an asymptote line at x equals 3. And that's a spot you can never cross on your graph. You can get closer and closer to it, but you're never going to touch it. All right. Thank you for asking. Okay, back to this one. We need to factor that. You guys are pretty good at factoring now. You just came off your factoring test. Please, factor it. Yes. I think let me check to see if I've already taken it, but for right now, would you please factor that? I'll pause for a second while you're factoring. Okay, so the top part, 2 sets of parentheses. Bottom part, 2 sets of parentheses. And also, something comes out at the very beginning, too. 4 comes out. There's not an x in everything, but there's a 4 in everything. So I'm going to factor that out. I have x squared plus 4. No, that 4 comes out. And I have x squared plus x. And then I have minus 6. And then that part will factor. So I have a 4. And then an x minus 6. And then x. That's not going to work. What else makes 4? 8 and 3 makes 4. I'm trying to find something that factors and makes a middle term of 4x. You guys factored it yet? What'd you get? X what? Minus 2 and plus 3? That has an outside and inside of positive x. Oh, that's right. I'm trying to factor it to this. I forgot I was trying to factor it so that it had a middle term of 4x. But that's gone now. And I have now got the top one, and now that makes sense. Okay. All right. And now this one has an x in everything. And then I break it out, and I get 2x squared plus 5x plus 6. And this one How do I make a 6? Probably a 2 times 3. So I probably have a 4. Not 4. Next. Excuse me. It's close to blowing out the microphone there. And now the 6 I could probably make with 2 times the 3. And then I want the middle term to be positive 5x, so they both need to be pluses then. And there we go. Raise your hand if you factored that quicker than I did. Nice job. Okay. Now on this one, I see that there's a hole. So I would always do these problems from the bottom up. It's good advice. You're going to have a bunch of them on your homework. You're going to have them on a test. The next test you have has this on. To the bottom up. Start with the hole first and say, okay, where was the hole? The hole is at x equals negative 3. And remember, on the test, you'll have to write that as negative 3 comma something. And all you have to do is take the negative 3, stick it in the function, like when you stick in a negative 3 here and here and here, and you figure out what the answer is. We're not going that far today, so you can just say x equals negative 3. The vertical asymptote. The vertical asymptote is the other things that crash it. I will circle them in blue. That and that could also crash my function, and they're not holes. So x equals 0 for that one, and x equals negative 2 for that one. Those are your verticals. And the last thing is the domain. The domain is all the numbers you could put in that wouldn't crash this function. So you say all real numbers, a big R with 2 lines on the side there. That's how you make the big R for real. And then, what are the things that would crash my function? All of these things. That, and that, and that. So you say x cannot be 0, because if it was, the whole function would crash. And x cannot be negative 2, because if it was, put it right there, the whole thing would crash. And x cannot be negative 3. And the common mistake is kids want to include 2, because they think, oh, can't be 2 either, but then the top would be 0, and that's okay. It's okay for the top to be 0. It's not okay for the bottom to be 0. Let me just take 2 seconds to remind you about that. If I have 0 cookies and I divide it amongst 3 friends, how much will they each get? And so that's okay. This is totally okay. If I have 3 cookies and I divide it amongst 0 friends, that's impossible. No, I have 3 friends. There's no other person. I don't exist. And if you really want to have your mind blown, don't interrupt, please. If you really want to have your mind blown, if you have 3 cookies and you divide it amongst 0 friends, they all get infinite cookies. Because actually that's the answer, is infinity. But it's actually forced to not be that, because that didn't make mathematical sense. And so they required this to be undefined. Think about it. If you divide 3 by something really small, close to 0, if you divide it by would you agree this is really close to 0? 0.0001. If you divide that, it's like 3,000. 3 divided by 0.001 is like 3,000. If you make it more extreme and you go, divide it by that then, that's really even closer to 0. Then it's like equal to 3 million or billion or something. And so technically, if you have 3 cookies and divide it amongst 0 friends, they all get infinite cookies. All right. The moral of the story is have cookies and don't have any friends, and then you'll have infinite cookies. Okay. All right. I think we should start working on your homework because it's a lot like this. And then we aren't going to be, you won't have the feeling like, oh my gosh, I'd like to get to my homework. So let's do your homework together. So everybody find your homework. It looks like this. It says 9.7 worksheet A. Here it is. Vertical asymptotes. It'll ask you for what it wants. In this graph, all they ask is for the coordinates. Some of you guys are still talking and you shouldn't be. Stop. I want to get this started here, and then you can chat at the end. All right. Have you got this worksheet up yet? If you haven't found it yet, it's on Schoology. It's 9.7, worksheet A. I'm going to start your homework with you. It'll make your life better this weekend. All right. Give the coordinates of all holes. Ooh, it says coordinates. Maybe we should actually do this as coordinates, because that's what you're going to have to eventually do, and I don't want you to be behind. So What are the holes? Well, first of all, you just go x minus 3 over 3 parentheses x minus 3. And then I can see that there's a hole here. Cancel, cancel. The hole was at x equals 3. And when I put in, this is y equals, when I put in 3, x equals, is it x equals 3 that crosses? Yes, x equals 3. What would y be? It's whatever's left here. Do you get what's left? Y equals 1 over 3. Do you get that when they canceled things? I was being kind of sloppy. When I cancel things, I was making it disappear. When I cancel things, what really happens? They equal 1. So when I canceled this and this, do you get that that's really a 1 over 3 times 1? So that's really 1/3. You don't get that when they cancel, they make 1s? Okay, because really, when you cancel, they make 1s. And then you get this, and then you get 1/3. That's why this is 1/3. We'll do another one together here. It's not that bad. Next one. I can see, oh, just cancels and cancels, but you don't want to make it like disappear. They turn into 1s, so the answer is 1. And now your hole is at, well, what causes the hole? If x is what? -5, comma, and then the other thing is whatever's left. What's left when you actually do put in 1? So the hole would be at -5, comma 1. If you want to picture what that would look like, it would look like this. Y equals 1 is a line that comes like this, and there's a hole when you hit 5. It'd be like an empty spot right there. And what they're saying is, where's the coordinates of that hole? And you go, oh wait, I went to +5 and I meant to. I hate when that happens. Back. I just deleted the whole page. You're right. Somehow I got out of Smart Notebook. I don't know what just happened there. There we go. Okay. All right. So it's supposed to be over here. Sorry about that. I was just trying to show you where this hole would be. And it's 5 spots to the left of the origin and up 1. All right. So I've done 1 and 2 with you. I know there's a chance that some of you will want extra help individually. You are welcome to ask me. And the rest of the hour you have to just crank on these things. Mostly it's factoring stuff, seeing where stuff cancels. If this part gets confused, or you get confused, go to this part, because this part to what we were doing in class, the second part of the worksheet is much more like what we were doing in class. And considering the amount of time I have taken in this hour, I'm going to let you skip number 12. It'll save you a bunch of time.